When a new AI support tool promises to handle your customers perfectly, you assume it will work like magic. You expect instant answers and zero errors because the code must be flawless. But what if the problem isn't the software at all? What if the failure happens because the physical hardware simply cannot hold the answer without breaking the bank? Today, we connect that frustrating customer experience to the engineering trade-offs behind the hype, specifically how GPU VRAM limits force developers into destructive shortcuts. The frustration you feel when an AI support bot hallucinates or freezes is not a software bug waiting for a patch. It is a physics problem rooted in the very chips running your application. When teams deploy these systems at scale, they face what researchers call omission and commission errors, driven by hardware incapacity rather than bad logic. These are mistakes where engineers must underestimate their system's ability to handle complex queries or bypass constraints entirely just to keep costs viable for their business model. The core conflict lies between marketing promises of seamless intelligence and the engineering reality that demands aggressive cost-cutting. To fit powerful models onto consumer-grade hardware or cost-optimized inference devices, developers are forced into a process known as quantization. This involves reducing the precision of the numbers inside the neural network to shrink its memory footprint. While this allows the model to run on cheaper chips, it directly degrades accuracy and leads to the very hallucinations users perceive as incompetence. Consider the recent scrutiny surrounding devices like the Rabbit R1 or the Humane AI Pen. These early adopter products failed not because they lacked software logic, but because their physical infrastructure could not execute complex tasks fast enough with sufficient context window size. A device might theoretically understand a request to check rideshare status, yet fail in practice because the GPU memory bandwidth cannot sustain the required inference speed without overheating or stalling. The gap between AI hype and user reality is often just this hardware latency problem in action. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This phenomenon creates an illusion of capability that crumbles under real-world load. When systems are deployed at scale, engineers face a brutal choice: build for perfect performance, which requires massive GPU clusters costing millions, or cut corners to make the product affordable. The latter path leads to aggressive downsizing where large models are squeezed into small buckets. This forces omissions where complex queries are dropped entirely because the system cannot process them within the latency budget required by human patience thresholds. The evidence for this is stark in recent field studies involving customer service representatives. In a study conducted at Guangxi Power Grid Co., Ltd., 13 CSRs were interviewed to understand how these tools impact their daily work. The findings revealed that AI failures force operators into a double bind where they must manage their own performance metrics while simultaneously compensating for the system's inability to handle complex queries due to latency and precision loss. These hardware-induced failures shift the burden directly onto human workers. Instead of just typing tasks, representatives now face increased psychological stress from managing errors caused by the underlying architecture. The study identified 3 core types of uncertainty affecting user gratification that stem not from bad data but from these physical constraints. When a system cannot answer correctly in real time due to memory bandwidth limits, the operator must step in to fix it, turning an automated solution into a manual troubleshooting session. For developers and engineers building or selecting AI tools, this shifts how you approach system design entirely. You stop looking for tuning prompts as the primary fix and start making informed trade-offs between model size, precision through quantization, and latency based on your available hardware budget. Understanding that failure is often an infrastructure problem rather than a coding error changes your perspective from debugging code to optimizing resource allocation. The future of AI support isn't just about bigger models or faster algorithms in isolation. It requires smarter allocation of physical resources to balance cost, speed, and accuracy. Practitioners must evaluate whether an AI feature is viable at scale based on VRAM constraints rather than just algorithmic potential. A smarter model does not always mean better user experience if the inference cost is too high or the latency is unacceptable for your specific hardware environment. We often blame the software when a customer feels ignored by a bot, but we should look deeper at the silicon driving it. The choice to use aggressive quantization was likely made to keep prices low enough for mass adoption, yet this decision directly impacts user trust and satisfaction rates. Every time you see an AI fail in support, remember that it is often a symptom of a budget constraint enforced by physical limits on memory bandwidth and VRAM capacity. This reality demands better engineering judgment from the industry. We need to stop treating hardware limitations as invisible background noise and start acknowledging them as primary design constraints. Until we build systems where cost-effective inference can match theoretical capability, users will continue to face these frustrating gaps between expectation and performance in their daily interactions with AI support tools. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.